Hello everyone and welcome back to yet another lecture on gradient of a scalar function. Now in this particular lecture we learn what is unit normal vector to the surface and angle between two surfaces. So both this topic comes under gradient of a scalar function. Now what is unit normal vector to the surface? So if phi is a scalar function, phi of x comma y comma z be a scalar function, and if we put phi of x comma y comma z equals to some constant c, then it represents a surface, right? Then what is the unit normal vector to this particular surface? Suppose this is the surface. So what we have to find? Unit normal to this particular surface, and which is nothing but n cap. And how will find n cap? Gradient of phi divided by magnitude of gradient of phi. Or if we take only if we simply take magnitude of gradient of phi, then it represents what? Normal derivative. So it's very simple. Okay, now let us do some examples. In the first example, what we have to do, find the unit normal vector to the surface. One surface is given, x square plus y square equals to z, and the point is also given 1 minus 2 and then 5. So first we have to suppose that phi equals to x square plus y square minus what? Z. After that we will find gradient of phi. So gradient phi is what? I del del x plus j del del y and then k del del z. So let us differentiate it partially. So del phi by del x. So when we differentiate with respect to x, derivative of x square is how much? Twice x. And if we differentiate y square with respect to x, it will become 0. Similarly, derivative of minus z is also 0. So we only have twice x. Similarly, j cap into, now we are differentiating with respect to y. So first term will become 0 because there is no y. Last term is also 0. So derivative of y square is how much? Twice y. So in the same way, del phi by del z will be about minus 1. Now we will find grad phi at the point 1, minus 2 and then what? 5. So in place of x we have to put 1. So it will become 2 I cap, and then in place of y we have to put minus 2. So it will become minus 4j, and then there is no z. So it will be simply what? Minus k cap. Now we have to find the magnitude. So it will be root over 2 square minus 4 square and then minus 1 square. So it will become 16, 20 and then 1, 20 root over 21. So after that we have to find unit normal to the surface. So therefore unit normal is equals to what? What is the formula? Nabla phi divided by magnitude of nabla phi. Okay. So if you want, you can denote it by n cap also. So this is 2 I cap minus 4 j cap minus k cap divided by root over 20. So it's so simple, right? Let us take another example. So find the unit normal to the surface. Here the surface is a little bit different. Okay, in the earlier problem there are only 3 terms. So here it is given that there are 4 terms. Okay. So let phi equals to x square plus xy plus y square plus xyz. So if we do the derivative perfectly, then answers are very easy. So first gradient of phi. So gradient of phi is again del phi by del x, j del phi by del y, and then k del phi by del z. So if you want, then you can write I cap, j cap, k cap. So here I am omitting the caps. So I into del phi by del x. So this is our phi, right? This is phi. So we have to differentiate this phi with respect to x. The first term is x square. So if we differentiate x square, what we will get? Twice x plus. In the second term there is x. So derivative of x is how much? 1, and y will be constant. And then in the third term only y square is there, no x, so it will become 0. Similarly in the fourth term there is one x. So if we differentiate x, we will get 1, and y and z will remain same. So this is del phi by del x. So similarly j cap into, now we will differentiate phi with respect to y. First term will become 0, from the second term we will get only x, third term twice y, and from the last term we will get xz. Okay. And then k cap into, first term no z, second term no z, third term also no z. So in the last term we have only one z, derivative of z is 1. So we have x and then y. So now the point is given. So nebula phi at the point what 1, -2 and 1. So this point we have to put now. So after putting 1 in place of, after putting 1 in place of x, in place of y we will put -2, and in place of z we will put what 1. So if you put all the values, you will get -2, -2, and then here -2. So it is -2 I cap, -2 j cap, let us omit. Okay, and then finally in the last term x y. So x is 1, y is -2. So this is also -2 k cap. Okay, now let us find the magnitude. Root over -2 square, -2 square, and then -2 square. So it will be how much? Root over 12 means 2 root 3. So therefore unit normal is what? Nebula phi divided by magnitude of nebula phi. So it's minus, you can take minus common if you want, 2 I cap, 2 j cap, 2 k cap divided by how much? 2 root 3. Okay, so you can cancel 2. So minus 1 by root 3 is common. I cap plus j cap plus what? K cap. I j k. So you can omit the cap. Okay, so this is the answer. So this problem is also very simple. Now let us come to the third problem. Here what to find? Find the normal derivative to the surface x square y plus x z square at the point -1, 1 and then 1. So again the function is what? It's slightly different, but what to find? Normal derivative, not unit normal. Okay, this is not unit normal. We have to find here normal derivative. So in the same way we will start. Let phi equals to x square y and then xz square. So first let us find gradient phi, which is I del phi by del x, j del phi by del y, and then k del phi by what? Del z. So I into, now we will differentiate this with respect to x. So in the first term there is x square, so it will be twice x and y will remain same. In the second term only x is there, so we have what? Z square. Then j into, in the first term y is there, so x square into 1, and then in the second term there is no y, so it will only x square, and then k into, first term there is no z, here we have 1z, so it will be x into differentiation of z square is 2z. Okay, this much we will get. Now what you have to do? One point is given, so you have to find gradient of phi at the point -1, 1 and then what? 1. So if we put -1, 1 and 1, what will get? It will become -2 and 1. So it will be only I cap. In the second term, in place of x, if we put -1, -1 whole square is 1, so it will become j cap. Third term, x is -1, so it will be -2 k cap. Okay, now it is normal derivative. Normal derivative. Here we no need to find unit normal, we have to find normal derivative. So normal derivative is magnitude of what? Nebula phi. So just to simplify the magnitude, so it will be -1 square plus 1 square and then -2 square. So after calculation 1 plus 1 2, then 4, how much it is? Root 6. Okay, so let us take one more problem of this unit normal. Find the greatest rate of increase of phi. Okay, so greatest rate of increase of phi and normal derivative is same. So let phi is already given, so phi is equals to x y z square. So first find gradient of phi, I del phi by del x, j del phi by del y, and then k del phi by del z. So after differentiating, what we'll get? Yz square j into xz square and k into then with respect to twice z. So it will be 2xyz. Now point is given, nabla phi at the point 1, 0 and then 3. So y is 0, no? First term will become 0, last term will also become 0. So we have only this term, middle term. X is 1 and then this is 3. So you have 9 j cap. Okay, 9 j cap. Other two terms will become 0. Now what to find? Greatest rate of increase. So this is the other meaning of normal derivative. So normal derivative we use what? Magnitude of grade phi. So it is root over 9 square means how much? 9. Okay, so it's very simple. Okay, now let us see what is angle between two surfaces. Suppose two different surfaces are given, phi 1 and phi 2. So first we have to find what? Gradient of phi 1 and then gradient of phi 2. So like dot product, no? We know what is the dot product of two vectors is a bar dot b bar divided by magnitude of a bar and magnitude of b bar. So here also, if we find gradient of phi 1 and gradient of phi 2 and angle between these two surfaces is theta, then cos theta will be represented like this. Gradient phi 1 dot gradient phi 2 divided by magnitude of gradient phi 1 and magnitude of gradient phi 2. So problems are very simple. Okay. So let us see some examples. So what to do? Find the angle between the surfaces. So different surfaces are given. So let suppose phi 1. Okay. So phi 1 will suppose like this is x square plus y square. Let us take z on the right hand side. It will be minus z and then minus 3. So this is our phi 1. And then phi 2. Phi 2 will be x square plus y square plus z square minus 9. So in the same way, first what we will find? First we will find nabla phi 1 means gradient of phi 1. Gradient of phi 1 is what? I del phi by del x. So if we differentiate this with respect to, okay, let us write the formula del phi 1 by del x, j del phi 1 by del y, k del phi 1 by del z. So it will be I del phi 1 by del x. So only twice x, j into twice y and k into how much? Minus 1. Okay. So then nabla phi 1 at which point? Point is 2 minus 1 and then 2. So if you put this value, it will be 4 I cap. Okay. 4 I cap and then y is how much? Minus 1. So minus 2 j cap and then minus k cap. Okay. So nabla phi 1 is done. Also magnitude of phi 1 we have to find, which is root over 4 square minus 2 square and then minus 1 square. Okay. So if you calculate it, it will be 1621 root over 21. So this is for one function. And for the second function, in the same way, we will find nabla phi 2, which is I del phi by del x plus j del phi by phi 2 by del y and k del phi 2 by del z. Okay. So if we differentiate with respect to x, again you will get twice x, j into twice y, k into twice z. So then nabla phi 2 at the point 2 minus 1 and then 2. So if we put 2, 4 I cap minus 2 j cap and then 4 k cap, right? So let us find the magnitude. 4 square minus 2 square and then 4 square. So how much it is? 16 plus 16, 32. 32 plus 4 is how much? 36. Root 36 means 6. So now what to find? The angle between two surfaces. So if we suppose that the angle is theta, then the angle between the surfaces surfaces is. So what is the formula? What is the formula? Cos theta, right? Cos theta equals to gradient phi 1 dot gradient phi 2 by magnitude of gradient phi 1 and then what? Gradient phi 2. So all the values we have, gradient of phi 1 is how much? 4 I cap minus 2 j cap minus k cap, okay, dot then 4 I cap minus 2 j cap plus 4 k cap divided by magnitude of gradient phi 1 is root 21 and this is 6. So just you find the dot product. So when you find the dot product is 4 4 16 minus 2 is plus 4 minus 1 and plus 4 is minus 4 divided by 6 root 21. So 4 4 cancel out, 16 divided by what? Root 21. So after calculation it will be 8 divided by 3 root 21. So what we have to find? We have to find the value of theta. So theta is nothing but cos inverse of 8 divided by 3 root 21. So very simple problem, right? So let us take one last problem. Okay, so find the angle between the normals to the surfaces. One surface is given, okay, but two different points are given. So what we'll do, we'll make one surface with this particular point through this point and then another surface to this particular point. So let phi is how much? X square minus yz. So first find gradient of phi. Gradient of phi is what? I cap del phi by del x. So if we differentiate this with respect to x, it will get twice x. J del phi by del y. So it will become 0. So you will get minus z. And then k del phi by del z. It is minus y. Okay. Now what we'll do? We'll suppose that when we find at the point 1 1 1, so that will be nebula phi 1. So let us denote that nebula phi 1 at the point 1 1 1. So if we put the values, it's 2 I cap minus j cap minus what? K cap, right? So what is magnitude of nebula phi 1? Magnitude of lambda phi 1 is root over 4 plus 1 plus 1. So it is root 6. Then similarly, nebula phi 2. Let us suppose the gradient value at the point 2 phi 1 is phi 2. So that will be, if we put 2, it's 4 I cap minus j cap and then minus 4 k cap, okay, minus 4 k cap. So magnitude of gradient phi 2 is how much? 16 plus 16, 32, 32 plus 1 is root over how much? 32, sorry, 33. Now let us find the angle. So cos theta is nebula 1, nebula 2, gradient of nebula 1, phi 1, then gradient of nebula phi 2, okay. So grad phi 1 dot grad phi 2 divided by gradient of modulus of gradient phi 1 and modulus of gradient phi 2. So just to put the values is 2 I cap minus j cap minus k cap dot 4 I cap minus j cap minus 4 k cap. So this is how much? Root 6 and then root 33. So if you calculate, after calculation you will get 8 plus 1 9, 9 plus 4 13 divided by root 6 from 33 and this 3 root 3. So it will be 3 root 2 into 11, 22. So this one will get. So therefore our theta is cos inverse 13 divided by 3 root 21. So okay, so we have one lecture left out on gradient of a scalar function, where we'll do the last two topic on gradient of scalar function. So I hope you understand all the problems. So if you like my videos, then kindly subscribe and share. Thank you for watching.